How far will a ball travel if it hits a wall at the speed of light? At first, this may seem overwhelming because it's hard to grasp how fast the speed of light is. Let's start by making some assumptions. Firstly, let's assume Newtonian mechanics apply. The reason we do this is because when objects move so fast, the normal rules don't work on them. Secondly, let's assume that the ball doesn't roll and stops moving as soon as it hits the ground. Thirdly, let's assume that there are no external forces acting on the system, except for gravity. Finally, let's assume that the ball hits the wall completely perpendicular to the wall and at 1 meter above the ground. Now that we've gotten that out of the way, let's set up our experiment. There are a few physics principles that we will apply. First of all, because we stated earlier that there are no external forces, momentum is conserved. We can set this up in an equation. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This looks complicated, but all it says is that when the ball hits the wall at any speed, it will bounce back with the same speed. Now let's look at the motion of the ball. We can break its motion down into horizontal and vertical components. The horizontal and vertical components are independent of each other. This means that they have no effect on one another. Using this information, no matter how fast the ball hits the wall, it will fall to the floor in the same amount of time because the force of gravity is vertical while the ball's initial motion is entirely horizontal. In order to calculate the time it takes for the ball to hit the floor, we can use the Suvat equations. All you need to know is that if you know any 3 of the following 5 values, distance, initial speed, final velocity, acceleration, and time, we can find the other 2. We know that the distance the ball is falling is 1 meter. We know that its initial speed is 0 because its initial velocity is 100% horizontal. And we know that the acceleration due to gravity is 9.8 meters per second squared. This is just a constant, meaning it's a common value that scientists have calculated to be the acceleration due to gravity. Using this information, we can use an equation to find the time it takes for the ball to hit the floor to be 0.45 seconds. Now in this time frame, how far can the ball travel horizontally? Using velocities equal to distance over time and plugging in the speed of light and our time value from earlier, we can find that the ball travels 135,525 kilometers.
Created using Powtoon.